Many theorems in mathematics are of the form if P then Q, so it's important to understand what this means and also what other statements are equivalent to it. Let's start with a non-mathematical example of the form if P then Q. If it is raining, then I carry an umbrella. This statement makes a claim about what happens when it's raining, but it makes no claim about what happens when it's not raining. I may or may not carry an umbrella. Let's look at some of the other if-then statements that we can form from the if clause, it is raining, and the then clause, I carry an umbrella. All of these have formal names in logic. The converse is a statement we get by interchanging the if clause and the then clause. If I carry an umbrella, then it is raining. This particular converse is a false statement. Sometimes I carry an umbrella, but it is not raining. So in general, the converse of an if-then statement is not true. But there are many true statements in mathematics, many theorems in mathematics for which the converse is true. For example, the well-known Pythagorean theorem says that in triangle ABC, if angle C is a right angle, then a squared plus b squared equals c squared. Its converse is also true. If a squared plus b squared equals c squared, then angle C is a right angle. But there are many true statements in mathematics for which the converse is not true. For example, if a equals b, then a squared equals b squared. This is a true statement. The converse says, if a squared equals b squared, then a equals b. This is not a true statement because it could be the case that a equals negative b instead. So again, the converse of a true statement need not be true. Here's another kind of statement that we can form for our original statement. It is called the contrapositive. This is the statement we get by negating the if clause and the then clause, and then interchanging them. Back to our original non-math statement, its contrapositive is, if I do not carry an umbrella, then it is not raining. In general, if the original statement is of the form if P then Q, then its contrapositive is if not Q, then not P. Do you see that the contrapositive of any true if P then Q statement is also true? Suppose Q is not true. If P were true, then according to the original statement, Q would also be true. But it's not. So if Q is not true, then P can't be true either. This is what the contrapositive says. Do you also see that the contrapositive of the contrapositive takes us back to our original statement? These two facts together tell us that the original statement and its contrapositive are either both true or both false. One more kind of statement that we can form from our original statement is called the inverse. This is the statement we get by negating both the if clause and the then clause without interchanging them. For our original statement, the inverse says, if it is not raining, then I do not carry an umbrella. This statement is false. Sometimes I carry an umbrella even when it is not raining. Another way to look at the inverse is to note that it is the contrapositive of the converse. And since the converse of a true statement may be false, it follows that the inverse may be false as well. So in general, the inverse of an if-then statement is not true. One more thing we need to consider before we turn our attention to mathematics is what if the if clause has more than one condition? For example, if it is raining and if I go outside, then I carry an umbrella. This is a true statement of the form if P sub 1 and P sub 2, then Q. So we know its contrapositive is also true. But what is the negation of P1 and P2 are both true? The negation is either P1 or P2 is false, or both. So the contrapositive of the above true statement is also a true statement. If it is raining, the original is if it is raining and if I go outside, then I carry an umbrella. Its contrapositive is if I do not carry an umbrella, then either it is not raining or I do not go outside. So this brings us to our existence theorems in calculus. Let's use as our example the intermediate value theorem. It says, if f is continuous on the closed interval ab, and if d is between f of a and f of b, then there is some c in the open interval ab for which f of c equals d. This is a true statement. That's why we call it a theorem. It has an if clause. F is continuous on AB and D is between f of A and f of B. And it has a then clause. There is some C in AB for which f of C equals D. What does its contrapositive say? We have to interchange the if clause and the then clause and negate both of them. How do we negate there is some C in the open interval AB for which of f of C equals D? The negation of there is some C is there is not some C, or more nicely put, there is no C. How do we negate f is continuous and D is between f of A and f of B? The negation of P and Q are both true is one or the other or both of P and Q must be false. So the negation of f is continuous on the closed interval AB and D is between f of A and f of B is either f is not continuous on the closed interval AB or D is not between f of A and f of B. So the contrapositive of the intermediate value theorem says if there is no C in the open interval AB for which of f of C equals D, then either f is not continuous on the closed interval AB or D is not between f of A and f of B.